Hi, hello everyone. Welcome back to the Cruz engineering videos. So in this video, we'll be discussing and solving problems involving the fluid flow and pipes in hydraulics. Okay, so let us call this one as part 1 because we'll be having series of discussions on fluid flow and different kind of problems involving Bernoulli's equation and any types of flows in a pipe. All right. So most commonly board exam type questions. This is intended for um, students that will be taking the board exam on their upcoming board exams. All right. So let's begin with the principles and formulas we need to understand or to know to attack problems. So we have the formula of the volume flow rate that is denoted as Q is equals to the area, cross-sectional area of the flow times the velocity of the flow. So basically this V is the mean velocity. And we have the mass flow rate that is density times discharge, Q, and the weight flow rate that is gamma or the unit weight times discharge. So basically, yung weight natin is just, we can express that as mass flow rate times the gravity because the relationship between this unit weight and density is we have that unit weight is equals to density times gravity. Alright, so ito yung mga terminologies natin. A is the cross-sectional area, V is the average velocity, rho is the density, gamma is the unit weight. So we can use this continuity equation in solving Bernoulli's equation problem. The flow rate at point 1, as you can see here, yung papasok dito, must be equals to the flow rate at point 2. So let's not complicate things. Ganitong mga klaseng problems lang yung mga lumalabas sa board exam. May mga may type dito or may scenario dito na the mass flow at the point 1 and point 2 are not equal, but that is very rare, no? Hindi yan lalabas sa board exam. So for incompressible fluid, that is, we can have that the density is constant. That's why we can have a discharge at point 1 is equals to discharge at point 2. Yung papasok dito, of course, yan yung lalabas doon. Okay? Alright. So, energy equation. So, the total energy in fluid mechanics or hydraulics, we denoted that one as energy head. Yan yung ginagamit natin dyan, the energy head. As we all know that the energy is expressed in a unit kilonewtons meter, pounds feet, or expressed into energy, no? Diba energy is like the unit of a moment, force times distance. But in hydraulics, most commonly, yung energy natin is expressed into head, no? Into unit distance or meters or feet, mga ganyan. But in our board exam sa Pilipinas, commonly metric system yung ginagamit, no? Naka-meters tayo. So this term here, v squared over 2g, that is a velocity head. This one is the pressure head, P over gamma, and Z is the elevation head. Okay? Now, the Bernoulli's equation energy theorem along a streamline, ito yung general equation natin, no? Most commonly, unang natin makikita is the energy at point 1, the total energy at point 1 must be equal to the total energy at point 2. If we have a pump between points 1 and 2, then we can have the head added, HA, head added. So you can see the meaning of this here dito sa baba. If we have turbine between points 1 and 2, then we can have head extracted minus because that is extracted. Dito naman, if head loss is considered, or the friction between the pipe and the fluid passing in this streamline is considered, then we can have the head loss. So in reality, may head loss talaga. No? But some problems neglect head loss. Right? That is equals to energy at point 2. So later on our sample problems, papakita natin how to interpret the energy grade line para mas maintindihan natin yung Bernoulli's equation. Okay? All right, so we have also to know this formula, no? Because sometimes in the Bernoulli's equation problem will be involving head loss, and if we need to calculate head loss given yung these mga parameters nila, then ito yung mga formulas natin for 𝐤𝐤𝐻𝐿, Mannings, and 𝐻𝐤𝐻𝐿. So how do we know kailan natin gagamitin Darcy, Mannings, and 𝐻𝐤𝐻𝐿? It depends on the factors given. So yung mga factors dito is yung friction, F, for Mannings, N yung binigay, for 𝐻𝐤𝐻𝐿, C, C yung constant na factor. No? Pag F yung binigay, friction resistance factor, then we'll be using 𝐤𝐤𝐻𝐿. If N naman yung binigay, that is coefficient of resistance, I think. You can check this on the internet, ano yung meaning dito, at yung C. Okay, so ito yung mga head losses na gagamitin natin. If hindi naman binigay yung friction factor, then we can calculate that using the this formula for laminar flow. We also have the turbulent flow, but most commonly laminar flow yung kukonsider natin. May ibang formula to calculate the friction on the turbulent flow, but you can just check that formula on the internet. Right? So dito most commonly mga board exam type problem yung iso-solve natin. Okay, so I think we are prepared to discuss and solve problems, no? That I prepared here by using these principles and formulas. All right. So before we start, let me plug this one here, no? The GRTC review, no? 𝐤𝐤𝐻𝐿 Engineering Review and Training Center. So GRTC offers some online review that will maybe help you on your civil engineering journey, no? So currently GRTC offers intensive review now, no, for the May 2021 board exam. But may mga offerings din dito sa YouTube channel ni 𝐤𝐤𝐻𝐿 Engineering Review and Training Center. May YouTube channel siya. May offering na GRTC Review Lite where you can enjoy the 13 weeks review na dinediscuss last time, and you can enjoy that on the GRTC YouTube channel. But of course, may konting payment rin, that is because that lectures was done similarly sa kung ano yung diniscuss sa physical classes. Okay, so you can avail that, and you can check these offerings here on this FB page, 𝐤𝐤𝐻𝐿 Engineering Review and Training Center. You can check this page here, and you can see the portfolio of services, no? You can check ano yung gusto nyong i-avail dyan online, no? All right. Okay, so if you want to avail those services, please check this page here and just message, no? Ano yung mga services na gusto nyong ma-avail. All right. So let's start to solve this problem. Water enters the mixing device shown in the figure at 160 liters per second through pipe A. Alright, ito. While oil having specific gravity of 0.8 is forced in 40 liters per second through pipe B. So, papasok siya dito yung oil. The liquids are incompressible and from a homogeneous mixture of oil globules in water. The diameter of the outlet pipe C is 36 centimeters. So here, what is the what is the weight flow rate of oil entering at B in newtons per second? The average velocity of the mixture leaving in C. The density of the mixture leaving at C in kilograms per cubic meter. Okay, so for number 1, that is direct substitution. By the way, yung mga given dito is naka liters per second. So dito sa figure, kinonvert ko siya into cubic meters per second. Just divide that one by 1,000 para maging cubic meters per second. Okay? This is for A, 160 liters per second. For B is 40 liters per second. Alright, part 1. The weight flow rate is given by this formula. Unit weight times the discharge. Well, at point B, that is oil, therefore the density must be Sg times unit weight of water, 9810 newtons per cubic meter, times the discharge, 0.04 cubic meters per second, and we have here 313.92 newtons per second. Okay, just follow the units, no? Dapat cancel out. Of course, this unit weight is in newtons per cubic meter. Ito, cubic meters per second. So the cubic meter can be cancelled out. Then yung matitira is newtons per second. Alright, what is the average velocity of the mixture leaving at sea? Average velocity. So in order for us to calculate the velocity, dapat may discharge tayo. Discharge at sea or Q sub C. Okay, so how can we calculate the discharge at sea? Now, as the problem states that the liquid are incompressible, so therefore, it is assumed that yung water and yung oil is completely mixed here dito. Kumbaga, nag-mix talaga siya, no? That's why yung density here must be equals to the density dito. So we can simplify the thing here that the QA plus QB must be equals to QC. Pwede natin gawin yan. No? QA plus QB is equals to QC. Again nga, it is incompressible. That means that the density of QA plus QB must be equals to QC. Okay? So we can have this one. So by this one, yung QC is equals to area times velocity. So we have here the diameter at C. Then we can express this one as pi over 4 times the diameter squared times the velocity at C, which is yung hinahanap sa number 2. Of course, we have the QA, we have the QB, we have the diameter here, as I have said. Then VC can be calculated. That is 1.96 meters per second. Alright. How about part 3? What is the density of the mixture leaving at sea in kilogram per cubic meter? So if hinahanap yung density, saan natin makikita yung density dito? Anong formula yung dapat natin gamitin? We must use the mass flow rate formula because we have that as density times discharge. Alright? So by that, we can say the general equation of the continuity, that is the mass flow. Mass flow dito must be equal to the mass flow yung lalabas. No? Mass flow at A, mass flow at B. So dito, iba-iba pa yung density nilang dalawa. No? Iba-iba pa yung density nila. Must be equal to the mass flow at C. Pag dito, pumasok na yung water at yung B, dito nag-mix na yung ating density nila. Kumbaga, may average density na tayo dito, which is lalabas sa C. Alright? So the mass flow, we know that the formula is density times discharge. So we have here, the density of water is 1,000 kilograms per cubic meters times the discharge is 0.16. Plus, ito, yung mass flow at B, ginawa ko na lang is weight flow of B over the gravity. Okay, as I have said kanina, that the weight flow is equivalent to the mass flow M times the gravity. Okay? That's why that the mass flow cross multiply yung G dito, that is weight over the gravity. Okay? Is equivalent to ito, the density of the mixture here times the flow at C. Take note that the flow of C is equivalent to flow rate of A plus flow rate of B. Yan yung equivalent. Yung flow nila is pag ganyan. Ganyan. Alright? So we can solve the density of the mixture equivalent to 960 kilograms per cubic meters. Okay? Situation 2 tayo. The oil is flowing on the pipe under conditions shown. Okay, so in this figure, we have the reference datum here, and we have the elevation at 0.1 and 0.2, 3.5 and 1.2 meters. Okay, yung given is the pressure at 0.1, 450, discharge at 0.1, 2.3 liters per second. We have the diameter at 0.1. We have the diameter at 0.2. Okay, what is the value of Q2 in liters per second? Okay, step by step tayo. So take note, for the continuity equation, isang liquid lang yung pumasok dito. And of course, yung lalabas is the same liquid lang. So we can just equate this one. Q1 is equals to Q2. Therefore, Q2 is 2.3 liters per second. That is very easy. No? Sometimes, tayo yung nagpapa-complicate sa problem. Alright. Number 2, find the pressure at point to neglecting a head loss. So, how can we solve the pressure? Dito, magagamit natin na yung Bernoulli's equation. Okay? Bernoulli's energy theorem. So, in this case, neglect head loss, and take note, wala tayong pump or turbine in between them. Walang mga machine. Then, we can just say that the energy at 1 must be equal to the energy at 0.2. No? And take note that the energies are composed of velocity, pressure head, and elevation head at 1. So, subscript natin ang 0.1 and 0.2. So, take note that we don't have the value of velocities of 0.1 and 0.2, but we have the discharge. No? Therefore, we can calculate the respective velocity at that point. So, the velocity is equals to discharge over the area. I-cross-multiply lang natin yung area. For B1, the discharge is 2.3 liters per second. Converted natin siya to cubic meters per second divided by its cross-sectional area. That is pi over 4 times diameter, 150. So, gawin natin meters, 0.15. We have here that value. For 2, change na natin yung diameter. Naging 250 na siya dito. Mas lumaki. So, 0.25 meters. Then, we have here the velocity. So now we can plug these values here. Then yung hinahanap is the pressure. So we can calculate this pressure here by directly substituting these values. Okay? So V1 here is ito over 2G, the gravity, plus pressure at 0.1 is 450 over the gamma. Take note that this is not a water, yung liquid na nagflow dito. That is an oil, no? With specific gravity of 0.84. Therefore, multiply pa natin yung unit weight of the water to the specific gravity, 0.84. Plus, the elevation head dito is 3.5 from the reference datum is equals to velocity at 2 over 2G plus P2 over gamma of the oil plus the elevation here. Then solve natin si P2. That is 469.01 kPa. Alright? Madali lang. Now, as you can see, for number 3, if the head loss from 0.1 to 0.2 is 1.2 meters, find the pressure at 0.2 kPa. That means, we'll be considering the head loss. Idagdag lang natin yung head loss sa equation natin dito. Okay, but before that, let's draw the energy grade line here. Para mas ma-visualize natin itong equation na to, yung Bernoulli's equation. Now, from the point 1, from the reference datum, we have the potential energy Z. Ito yung Z1 natin, 3.5. Ito is composed of velocity and the pressure head. So, aangat tayo dyan. Then, ito naman, V2 squared over 2G plus P2 over gamma. Yung ibig sabihin dyan, ito yung energy grade line natin. That this total energy here from here pa ganyan is equivalent to the energy here. Yan. Expressed in 2 meters. Okay? Ito yung ibig sabihin ng equation na yan. Now, if may head loss na tayo, therefore may mawawala tayo or may drop from 0.1 to 0.2. So, magiging ganito yung energy grade line natin dyan. Okay? So, ito yung nawala or head loss. Nawalang head. Na? Yan yung ibig sabihin ng head loss. So that is 0.2. So again, we'll just input this head loss here. Of course, that is minus. As you can see in the figure, this total energy here, minus na natin ng HL, then that will be the total energy here. That is energy at 2. Ito. Alright? So, substitute lang, the same sa ginawa natin kanina, but we have here the head loss. Solve natin si P2. That is 459.1 kPa. Alright? Now, for number 4, baliktad dito. If the pressure at point 2 is 436, so binigay yung pressure here, what is the head loss in meters? So, baliktad. Head loss naman yung hahanapin natin. Okay. I think you can just follow that one na. No? Alright. So, substitute. HL is unknown. We have the P2 here. Then, solve natin si HL. That is 4. Okay. So, let's have our last problem in this part 1. Okay. So, dito, may pump na tayo in between two reservoirs given. A pump draws 24 liters per second of water from reservoir C and lifts it to reservoir D as shown in the figure. The head loss from C to 1 is 3 times the velocity head in the 150 mm suction line, and the head loss from point 2 to D is 25 times the velocity head in the 100 mm discharge line. So, question here is the power delivered by the pump to the system. What is the pressure head at point 1 in meters of water? Pressure head at point 2, in meters of water. Now, as we can imagine, if hindi present yung pump dito, and point D is more elevated than point C, then the water must be flowing to C. Because mas mataas siya, no? Dapat pa ganyan. But because of the pump, ito yung gamit ng pump. Magkakaroon ng suction dito. Kumbaga, hihilahin ng pump yung water dyan. Kanya, din iaangat niya doon sa taas. Because of this machine. Now, to express this one, yan, no? Yan yung ibig sabihin dyan. Now, to calculate the value of the power of the pump, we need to calculate the head added of the pump, because power, hindi ko pala to napakita, no? Power is equals to unit weight times the discharge, or just the weight flow. Ito yung weight flow, but i-multiply pa natin siya by the head here. So in this case, this is the head added. Pwede rin, i-generalize natin H, but pwede rin siyang head extracted by the turbine. No? It's up to what machine we are using. Dito, this is a pump, so head added dyan. So to solve that, dapat makuha natin yung HA, then dapat ma-involve natin yung pump sa equation. So take note that in Bernoulli's equation, pipili tayo ng dalawang points. So because these are reservoirs, we'll be taking advantage here. From point C to point D tayo. Kasi sa Bernoulli's equation, pwede rin point C to point 1. Pwede point C to point 2. Pwede point C to point D. But first attack natin is to know a simplified approach, no? Or to know how can we solve this problem without getting complications. Because if gagamitin natin yung point C and the point 1, maraming unknown sa point 1. We don't have the pressure. We don't have yet the velocity, but we can just calculate that. No? Yan. Velocity and pressure yung wala natin. But, ito yung i-take note nyo. Pag reservoir, if this is the water line, then the velocity here, the velocity of flow is negligible. So, that means that is the velocity at point C is 0. Okay? Always yan basta reservoir. And also, that the velocity here, since that is a water surface or a free surface, the pressure head rather, no? The pressure head is equivalent to 0 rin. Okay? So, mas malaking advantage ito pag mga reserva. Zero velocity, zero pressure. Same as at point D. Therefore, if we equate the point C and point D, we can simplify things. Matitira dito is elevation na lang yung kinoconsider natin na energy sa reserva. Okay, so interpret muna natin. The head loss from C to 1 is 3 times the velocity head in the 150 mm suction line. So dito, again, suction to because hihilahin ng pump yung water dito. Then, ito, discharge line because ipupush ng pump papunta kay reserva D. No? So the head loss from C to 1 is 3 times. So 3 times the velocity head at 150 mm suction line. So let's denote that one as 3 times V1 squared over 2G. Now, the head loss from 2 to D is equal to 25 times the velocity head in the 100 mm suction discharge line. So V2 squared over 2G. Now, let's calculate the velocity. Calculate natin velocity in this pipe. So again, our main equation here is the energy at C minus the head loss from C to 1 minus the head loss from 2 to D. So, dalawang head loss tayo. Of course, may pump in between point C and point D plus head added of the pump is equivalent to energy at D. Solve natin yung V1 because we have here the discharge. So, 0.024 cubic meters per second over the cross-sectional area of this pipe. That is 1.358. Of course, V2 here is the same but nagbago yung pipe diameter natin dito. Solve natin si V2. Alright? Okay. So, solve natin yung velocity head, no? So, for 1, velocity head for this pipe 1, that is 0.094. The velocity is 1 at 1.358. Just input this one here over 2 times gravity, 9.81. And velocity head at pipe 2, that is 0.476. So, constant yung velocity natin dito, velocity head, because same dito from here to here, same cross-sectional area yung pipe, dito rin, constant sila. Now, from here, this equation is equivalent to that. Again, yung energy is composed of velocity head, pressure head, at elevation head. No? Ito rin. Ito yung energy at D. But as I have said kanina, walang velocity, walang pressure. So, automatically, yung matitira sa point C and point D na energy are the elevations lang. Okay? So, we can have this one. Zero energy at C, because yung elevation niya is zero rin. Automatically, this one here is zero. Okay? Minus the head loss from point C to 1, that is 3 times the velocity head of this pipe. No? That means that is 3 times 0.094. This is the velocity head of pipe in this pipe. Take note that this is not the velocity head at point C. No? This is the velocity head on this suction line. Iba yung velocity head dito. Dito wala tayong velocity head dyan because walang flow dyan. Okay? So that's why 3 times 0.094. Head loss from 2 to point D, we have here 25 times. Saan yun? Ito. 25 times the velocity head on the discharge line. So the velocity head here is saan yun? Nakuha ba natin ito? Nakuha natin yan. 0.476. So that is 25 times 0.476. Then of course, plus the head added by the pump, equivalent to the energy at D. Again, the energy at reservoirs is equivalent to the elevation automatically. Okay? So, solve natin si HA. Now, to solve the power, we can use this formula. Unit weight, discharge times head. So, yung head natin dyan is the head added. So, we have here, unit weight of water, kilonewtons per cubic meters times the discharge, 0.024 cubic meters per second. Cancel out this one. Yung matitirang unit is kilonewtons meters per second. But take note, kilonewtons meters per second is equivalent to kilowatts, no? And convert natin siya to horsepower. So the conversion factor is in every 1 horsepower, we have 0.746 kilowatts, canceled out yung kilowatts, then the answer is 79.6 horsepower. 30. Alright? Okay, now, number 2. Medyo mahaba to, no? Before that, i-draw natin yung energy grade line para ma-understand natin to, itong equation ng Bernoulli dito. So, from C to point 1, hihilahin ng pump yung water dyan. So, from C to that pump, bababa tayo with a draft or the head loss from C to 1. Ayan. Ito yung from energy 0, di ba? From point C, yung energy natin dyan is the elevation alone. But the elevation here is 0. From 0, bababa tayo ng head loss C to 1. O kaya ganito. Head loss C to 1 is 3 times 0.094. Now, from here, iaangat yan ng pump yung energy grade line dyan. Iaangat meaning we have an abrupt change of energy grade line dyan. Aangat tayo by head added. Yung head added is 252.18. Yan, abrupt change. Actually, hindi naman talaga siya straight line. May konting slope yan, but that is negligible in the drawing, no? So, we have here head added. That is 252.18. So, from here, supposed to be yung arrangement talaga dyan is andito yan. But, of course, hindi na yan na magmamatter sa equation natin. From here to that, plus head added. Now, from this point of the energy grade line, bababa tayo ng head loss from point 2 to point D. So, ito yon yung binaba natin. 25 times the velocity head at point 2. So, bababa tayo. Of course, yung matitirang elevation dyan or yung energy is equivalent to energy at point D, which is the elevation at D. Okay? Yan yung ibig sabihin. Ito yung head loss ng point 2 to D. So, I hope you understand the Bernoulli's equation, no? The how to construct the energy grade line. So, iba yung hydraulic grade line because sa hydraulic grade line, we only consider the static pressure due to the liquid. Pag sinabing static pressure, we are not considering the movement or yung flow, no? So, basically, tatanggalin lang natin yung velocity head sa hydraulic grade line. Alright? Let's move to number 2. What is the pressure head at point 1 in meters? So, to involve the pressure head at point 1, so, by the way, yung point 1 is immediately before the pump. No? Immediately before the pump. So, andito siya. So, somewhere here. To involve the pressure at point 1, pipiliin natin na points to use in the Bernoulli's equation is C and point 1. No? Equate natin yan. Of course, as you can see in the figure, from energy at C minus HLC1, then equivalent yan to energy at point 1. But of course, yung energy at point 1, we have here pressure. We also have here velocity. No? Because hindi na siya reserva. So, by this equation, we know that the, okay, sinimplify ko pa siya dito. But again, this is equivalent to 0 lang because 0 yung elevation ng C. So we have here automatically HLC1 is minus 3 times 0.094 is equals to the energy at point 1. So ano yung mga energy natin sa point 1? That is the velocity head. Ano yung velocity head natin dito sa point 1? Automatically ito, V squared over 2G at 1, 0.094. Alright? Plus the pressure head. So, denote na natin as HP1 yung pressure head sa point 1. No? Plus the elevation. Now, the elevation here is negative 20. So, that is lower than the reference datum. Kumbaga, this point C is yung reference datum natin. So, plus negative 20. Then, solve natin si pressure head at point 1. Take note, hindi pressure yung hinahanap. Pressure head. Automatically, ganyan. Okay? Ala. Number 3. What is the pressure head at point 2 in meters? So to involve point 2, pwedeng gamitin natin dalawang points is point C and point 2. So from here to here, pwede rin from point 2 to point D. Yan. Pwede rin from point 1 to point 2. Yes, pwede yan. But I will show you here two solutions. Point C to point 2 yung gagamitin natin or point D to point 2 to point D. Sige. Pag gamitin natin point C to point 2, ano yung mga ma-involve? Of course, the energy at C minus HLC to 1. Of course, point 2 is immediately after the pump. So, somewhere here yan. Somewhere here, yung point 2. Ayan, dito. Okay? That means, i-add natin yung head added dyan. Kasali yung head added of the pump. Then, equivalent to energy at 2. But take note, the pressure head yung hinahanap dito, express natin yan to pressure head. Again, 0 yung EC, no? Because the elevation here is 0. Automatically, the head loss from C to 1 plus the head added, we calculated that one here, is equals to, ano yung velocity head at 2? Take note that the velocity head at 2 is 0.476. The pressure head at 2 plus the elevation here, the same as negative 20. Okay, solve natin si HP2. How about using these points, point 2 to point D? Alright, i-try natin. From point 2 to point D, so yung ma-involve dito, of course, lumagpas na siya kay pump. We don't need the value of HA. Andito na tayo sa point na yan. No? Yan. So, energy at 2 minus HL2 to D, of course, ma-involve na natin to, is equivalent to energy at D. Alright? So, again, energy at 2, we have pressure, we have velocity because nasa pipe yan, and we have the elevation. So, express natin yan. The velocity head at point 2 is ito, 0.476 plus the pressure head denoted as HP2 plus the elevation minus the head loss from point 2 to D. So the head loss is 25 times. Take note that this one is 25 times the V2 squared over 2G. So ito yon, 0.476 equivalent to energy at D, that is 240 yung elevation niya. Then yung lalabas is the same dyan. Okay? So, that's it for part 1 of fluid flow and pipes. So, probably on the next video will be a solving involving turbines, no? Dito pump tayo, turbines, and sa mga preceding videos natin, we'll be dealing with pipes in series, pipes in parallel, no? Parallel positions, and of course, yung reservoir problems, 3 reservoir problems na lumalabas sa board exam. We'll be discussing that one on our next videos. So that's it, and hope you enjoy and na-learn, no? Hope you enjoy and you learn from this video, and please like and share this to your friends if nakatulong ito sa inyo. Alright, so that's it and bye-bye.